Hey guys, welcome to our channel Tech and Talks. This is the third video of the sorting topic, and today our topic is insertion sort. So let's discuss about insertion sort. For calculate the insertion sort, in the first step, we start by making the second element of the given array as the key value. So we take here 12 is the key value because it is the second value of the given array. Now we compare the key element with the elements before it. We have to compare the key element with its before elements. Here the before element is only one element, that is 85. If the key element is less than the first element, it means if the key element is smaller than its before element, then we insert the key element before the first element. So 12 is lower than 85, so we have to insert the 12 before the 85 position, and it is not possible because before 85 there is no position. How can we store the 12 before 85? In the array we can easily access any element. If I shift the 85 in the right side, then it will come to the 12 position. At this time the first position is blank. At in this time I stored the 12 there, then 12 is here and 85 is here. So the third step is then we make the third element of the array as key and we'll compare it with elements to its left and insert it right position. It means we have to take the 59 again and same application again apply. Okay. And fourth step is, and we go on repeating this until the array is sorted. Now I take an example so that it will be clear. Here I take an array 85, 12, 59, 45, 72 and 51. Here the second element is 12, so I have to compare the second element with the first element. Here when we compare the 12 with 85, then we know that 85 is the largest value than 12. So we have to right shift the 85. When I right shift the 85, 85 goes to this position, mean 12 position, and I have to store the 12 now in the first position because first position is now blank. So I can easily store the 12 in the first position. So now these two elements are sorted. Now take the third element, take the next element. So we start here the second position. Now take the third position. Third position is 59. Now we have to compare 59 with its before elements. Now 59 before element is 85 and 12. At first compare 59 with 85. When we compare the 59 with 85, we see here that 85 is the largest value than 59. So we have to swap the 85 again to the right side. If we shift the 85 to the right side, then 85 comes to the 59 position, means the third index of the array. 85 comes to the third index of the array, and 50 at this time the second index is blank, and at this time I can easily add the 59 to the second position. I have to again compare it with its before element. Its before element is 12, so it is 12 is lower value than 59, so keep it as it is. Now we take the key value fourth index, that is 45. When you take the key value as 45, compare the key value with its before elements. Here the before element is 85, 59 and 12. When we compare the 45 with the before element 85, then we see there 85 is the largest value than 45. So we have to shift the 85 to the right side, and when it come to the fourth index, when 85 come to the fourth index, then we have to easily, then the third index is blank, so we can easily store the 45 in this position. When we store the 45 in this position, we have to again compare the 45 and 59. We can see that 59 is again the largest value than the 45, so we have to right shift the 59 again. When we right shift the 59 again, 59 comes to this place, 59 comes to this position. I can easily store the 45 in this position. When I store the 45 in this position, I have to check again that with its before element. When I compare the 45 with its before element, that is 12. So here 12 is smaller than 45, so keep it as it is. So now our sorted array is 12, 45, 59, 85. Now the next element is 72. So I have to compare the 72 with 85, and I see here the 85 is the largest value than 72. We have to shift the 85 to the right side. When you shift the 85 to the right side, it will come to the 72 values position, and at this time 85 where the previously 85 is stored, there is blank. So I can easily store the 72 here, because we can easily access any position of the array. After when we add the 72 here, now here is 72 value, here is 72 value. We have to compare the 72 with its before element. When we compare the its before element, then we find that 59 is there, and we know that 72 is the largest than 59, so keep it as it is. Now we take the sixth index, that is 51. We know that the 51's before elements are 85, 72, 59, 45 and 12. When we talk about the 51, we compare its before element with its before element. Its before element is 85, and we know that 85 is the largest value than 51, and we know that we have to right shift the 85. When we right shift the 85, 85 comes to the last position, and the previous position where 85 are stored, where 85 were stored, this position is now blank, and we can easily save the 51 at this position. Now 51 is the this position, and we have to again compare 51 with its previous element. When we compare its previous element, that is 72, that we see here 72 is the largest value than 51, so we again shift the 70 to the right side. When we take the 70 to the right side and store the 51 in this side, this place, now the 51 is in there, and we again compare the 51 with its previous element, that is 59. We again see that 59 is the largest value than 51. Again I shift the 59 to the right side, that 59 is here, and now the 51 is in this position, and again we have to check the 51 with its before element. Now the 45 is before element, and we know that 45 is lowest value than 51, so keep it as it. Now this is our sorted array. This is our sorted array. Now I will discuss the C language code of the insertion sort. Okay. So this is our code. Now this is the header file, hashtag include stdio.h. We all know it. And this is our main function, int main. And here I take the array length, that is 6. And here array 6 is equal to, I declare the values. Okay. Now what I am doing, at the first step we have to take the second value of the array. So we know that array start from the 0 position, but here between the for loop I take I is equal to 1. It means I take the second value, which is we flow, the loop will be flow to the end position, so I less than n. Then I take the key variable as 12. We know that the second value of the array is the key value, so I take here int key is equal to array of I, means 12 is the key value, array of I is array of 1. In this case array of 12 is the key value. When the loop will be flow again, then I is equal to 2, and in this case the 59 will be the array value, sorry, the key value, because 59 is now array of I. If array I is equal to 2, then array of 2 is equal to this value 59, and 0 array start from 0 index. Okay. Now when we talk about the 12, we have to compare its before element. Okay. For compare its before element, we assign the before elements index in a variable. That's why I take int j is equal to I minus 1. Now here I take a loop, that is while loop. Between the while loop I declare there for two statements, that is j greater than equal to 0 and array of j value less than the key value. The loop will be flow then when the j's value is greater than the 0 and the key value, the array of j value, in the case that array of j value is greater than the key value, it means that we know that array of j is the before element of the key value, because key is equal to array of I position, and we know that j is equal to here I minus 1, so array of j is the before position of the key value. If the before element is larger than the key element, then only the loop will be flow. Okay. In this case, array of j plus 1 is equal to array of j. Why I write this statement here? Array of j plus 1 is equal to array of j. We know that we have to store the 85 and the 12 position, because the first case when we take the 12, when we take the 12, in this case this statement is valid because that key value is 12 and array of j is equal to I minus 1. So here I minus 1 is equal to 85. So first index array of j is equal to 85. This statement is valid. And now looking this statement, when in this case j greater than equal to 0, so j's value is 0 now, because I take I equal to 1, so 1 minus 1 is equal to 0, so j's value is 0. This is equal to 0. For this reason these two statements are satisfied. For this reason that I write here array of j plus 1 is equal to array of j. We know that if the before element is larger than the key element, we have to right shift the before element. For right shift the before element, I take here array of j plus 1 is equal to array of j. It means array of j plus 1 is equal to this position, the 12th position, mean the second position. Take here second, in the second position we store the value of array of j. We know the array of j value is 85. Now 85 is in this position, 12th position, means the second position is now 85. Then j is equal to j is minus minus, so in the first case j is 0. Now j is minus minus means j is minus 1. Going this loop again, this statement is j greater than equal to 0, j value is minus 1. For the AND operator, we know if any value of the statement is false, then the whole statement is false. So if the while statement is false, then it will come this line, because here the ending point of the while loop. Now when it come in this position, array of j plus 1 is equal to key. Why I write here j plus 1 is equal to key? Now what is the value of j? In the last time when j, this condition is failed, because j is equal to minus 1, because at the first step j is equal to 0, j minus 1, j minus minus, so now the j's value is minus 1. In this case this statement is false, but j's value is still now minus 1. For this reason I write here array of j plus 1 is equal to key value is 12, so minus 1 plus 1 is equal to 0. So array of 0 value is now key value. Now array of j plus 1 is equal to key. It means that 12, the key value is 12. 12 is stored now. Array of j plus 1, j is equal to minus 1. So minus 1 plus 1 is equal to 0. So the 12 stores to the 0 position. Now what is the meaning of this line? It means that 12 is now the first position and 85 is now the second position. Okay. It will continued. This two loop will be continued until the whole array is sorted. So at last I write here the printf statement and return 0. Okay. One thing always remember, when you write the code, always do the back calculation. Okay. Now I run the code. When I run the code, the output is 12, 45, 51, 59, 72 and 85. This is our unsorted array. Here this is our unsorted array and this is our sorted array. Okay. I think you are understand. In the C++ language, what you have to do, just you have to do the change the header file and here add the using namespace std and change the printf function. It is your homework. When you perform this operation, then your C++ code will be ready. So if you like our video, if you enjoy our video, then don't forget to like, subscribe and share our channel with your friends.